Hi, welcome back to my class in Mathematics in the Modern World. For today, we will continue with our solution of the first transportation problem we had in the last meeting, in the last lesson. In the last lesson, we solved the initial transportation table and we developed the initial transportation plan corresponding to the initial transportation table. And this was the initial transportation plan we had in the last lesson, and we made the initial distribution using the stepping stone method. And based from this initial transportation table, we developed the initial transportation plan. And we said that we will try to test or determine if we can lower the initial transportation costs in the initial distribution plan. And our objective in transportation problem is to get or obtain the minimum transportation cost. To determine if we can still lower or make the initial transportation cost lower, we do the test for improvement. This is actually the second step in the stepping stone method. In the test for improvement, we will consider each of the vacant cells because it might be better if we transfer some units in some of the vacant cells. Like in this cell, the cell cost is 6 pesos compared to 13 pesos and 12 pesos. If we place some units in this cell, we would surely obtain a lower transportation cost. But we will determine in which of these 4 vacant cells we should transfer. And we do that by doing the test for improvement. We start with a vacant cell. We will call this vacant cell XB. For each vacant cell, we will trace a closed path. So we will start with the vacant cell XB, but you can actually start with any of the vacant cells. You can start with this vacant cell XC, or you can start with this vacant cell ZA or this vacant cell ZB. For our example, we start with the vacant cell XB. And as I said, for each vacant cell, we will trace a closed path using an alternating horizontal and vertical movement. It is a closed path because we will start from the vacant cell and we should be able to return back to the vacant cell. So it's a closed path. And this path will consist of alternating horizontal and vertical movements, always beginning with horizontal movement. And for the horizontal movement, the cost associated is the positive cell cost. For vertical movement, the associated cost is the negative of the cell cost. Again, the first step is always a horizontal movement. You may either move horizontally to the left or horizontally to the right. But when you move horizontally or vertically, you must never stop at a vacant cell. You must not go to the vacant cell. You must always land on an occupied cell. You must always land or stop at a cell with some units because we will try to get some units from the occupied cell and transfer that to the vacant cell. So if you go to the vacant cell, you will get nothing from the vacant cell to be placed at the at the vacant cell you are considering. So when you move horizontally or vertically, do not stop or land at the vacant cell. But in moving horizontally or vertically, you may skip an occupied cell, or you may skip a vacant cell. The first movement is always horizontal. From this vacant cell, we move horizontally, and we cannot move to this vacant cell because it has nothing. There's nothing in this vacant cell. There's nothing we can get from this vacant cell to transfer to this vacant cell we are considering. Thus, we move horizontally to the left up to 78. We indicate that by this arrow. As I said, the cost associated with horizontal movement is the positive of the cell cost. The cell cost from which we originated is 7. So the cost associated with moving horizontally to the left up to 78 is 7 pesos. And we write it here in the test for improvement. XB equals the first movement is 7 pesos. I mean, the cost associated with the first horizontal movement to the left is 7 pesos. After the horizontal movement, the next move is vertical movement. It's always horizontal followed by vertical, and then horizontal and then vertical. The closed path you will trace is a combination of horizontal and vertical movements, alternating horizontal and vertical movement, always beginning with horizontal movement. Here we started out with horizontal movement, so the next step is vertical. It's either you move vertically upward or vertically downward. Now, you cannot move vertically upward because this cell is not part of these cells we are considering. Hence, from this cell, 78, with 78 units, we move horizontally downward. And we cannot move up to, I said you can skip an occupied cell. You can skip this cell, and from 78 you go straight to this cell. But this cell is vacant. As I said, you cannot land or stop at a vacant cell. Hence, from 78 we move horizontally downward up to 9 only. And the cost associated with vertical movement, either downward or upward, is the negative of the cell cost. From 78, we moved to 9, and we originated from this cell with 78 units. The cell cost is 10. And you take its negative, you write minus 10. After the vertical movement, the next move is horizontal. Now, we cannot move horizontally to the left because this is one of the supplier. We move horizontally to the right. From 9, you move horizontally to the right. If you go straight to 2 and you skip 124, the next move is vertical. And you cannot move upward because it's vacant. And from 2 you can move downward, it's occupied, but the next move is horizontal, and this is vacant cell. Hence, if you move from 9 to 2, you will not be able to go back to this vacant cell XB where you originated, where you started out. So from this cell with 9 units, we move horizontally to the right up to 124. And that horizontal movement to the right we indicate by this arrow. And the cost associated with this horizontal movement is the positive of the sunk cost where you started, where you originated. In moving to 124, we started from 9 with sunk cost of 9. Hence, the cost associated with this horizontal movement is positive plus 9. After this horizontal movement, the next move is vertical. Now, you cannot move to this cell because it's vacant. The last movement is vertical upward. And if you move vertically upward, you will land at the vacant cell where you started, the vacant cell XB. And the cost associated with this vertical movement is the negative of the cell cost, where you came from in moving to this cell. And the cell cost from this cell with 124 units is 12, and you take its negative. You write minus 12. And this is the closed path I was telling you about earlier. For each of the vacant cell, we will trace a closed path, and a closed path consists of combination of alternating horizontal and vertical movements. And it is closed because we should end up at the same vacant cell where we started out. And we get the sum and difference of this number, 7 minus 10. That's negative 3. Negative 3 plus 9 is 6. 6 minus 12 is negative 6. Negative 6 is what you call the net cell cost. It is the net cell cost of the vacant cell XB. And the meaning of negative 6 is that if you transfer some units in this vacant cell XB, the total transportation cost will decrease by 6 pesos per unit. If you transfer 2 units in this vacant cell, the transportation cost will decrease by 2 multiplied by 6 equals 12 pesos. Again, if you transfer some units in this vacant cell, the transportation cost will decrease by 6 pesos. Or the negative net cell cost of negative 6 means that if you transfer some units in this vacant cell XB, the total transportation cost in the initial distribution plan will decrease by 6 pesos per unit. So it might be better if we transfer some units in this vacant cell. But we will not do that now because we still have other vacant cells to consider. We still have 3 vacant cells to consider. And we might get a much lower net cell cost for the other vacant cells. So you wait until you have considered all the vacant cell in the test for improvement, and then you decide in which cell you should transfer some units. Now we consider this vacant cell XC. Now I will remove this closed path for the vacant cell XD, because if we do not remove this path, our table will be full of arrows and it would be difficult for you to see the numbers. Okay, we now consider this vacant cell XC. Again, we will trace a closed path that will start from this vacant cell and that will end up at this vacant cell using a combination of alternating horizontal and vertical movements. And the first movement is always horizontal. So from this vacant cell, we move horizontal, either horizontally to the right, and we cannot do that because this is the supplies of the first supplier X. So from this vacant cell, we move horizontally to the left. And we should skip this cell because it is vacant. You should never stop or land at the vacant cell. You should always land on at an occupied cell. And as I said, you can skip a vacant cell or an occupied cell. Thus, from this vacant cell, we move horizontally to the left, straight to 78. And the cost associated for horizontal movement is the positive of the cell cost where you originated. And we originated from this cell in moving to this occupied cell. And the cost associated with this horizontal movement is the positive of the cell cost, which is 9. So we write XC equals 9. After the horizontal movement to the left, the next step is vertical movement, either vertically upward or vertically downward. And we cannot move vertically upward from 7 to 8 because this is not, this is the demand of customer A. Hence, from 7 to 8, we move vertically downward and we cannot move up to this cell because it is vacant. From 7 to 8, we move up to 9. And the cost associated with vertical movement is the negative of the cell cost where you originated. And we originated from 7 to 8 in going to this occupied cell with 9 units. So the cost associated with this vertical movement is the negative of this cell cost. Minus 9, we write minus 10. And after the vertical movement, the next move is horizontal. And we do not move horizontally to the left because this is a supplier. This is the warehouse, Y. So from 9, we move horizontally to the right. And we go straight to 2 because we should be able to get back or return to where we started in this vacant cell. If you move up to 124 only, you will not be able to go back here to your point of origin because if you move up to 124 only, the next move is vertical. If you move vertically downward, it's vacant. If you move vertically upward, it's also vacant. Hence, from 9, you skip this cell with 124 and you go straight to 2. From this cell with 9 units, we go straight to this cell with 2 units and we skip 124. And the cost associated with this horizontal movement is the positive of the cost in the cell where you originated. We originated from this cell in going to this cell and the cell cost is 9. The cost associated with this horizontal movement is plus 9. Finally, we return back to this vacant cell. So we move vertically upward. If you move vertically downward, the next step is horizontal and it's vacant and it's vacant. Hence, from this cell with 2 units, you go back straight to your point of origin. And the cost associated with this vertical movement is the negative of the cell, of the cost of the cell where you started in moving back, returning back to this vacant cell where you started. And the cell cost for this cell is 8. Hence, the cost associated with this vertical movement is minus 8. Again, this is the closed path I was telling you about earlier. It's a closed path because we started from this vacant cell and we end up at the same vacant cell. And it's a path because it's a combination of alternating horizontal and vertical movements. Now we find the net cell cost for this vacant cell XC by adding these numbers. 9 minus 10 is negative 1. Negative 1 plus 9 is 8. And 8 minus 8 is 0. Now 0 is neither positive nor negative. 0 is not positive and it is not negative. The meaning of a net cell cost of 0 is that if you transfer some units to this vacant cell, you can transfer some units to this vacant cell. But that action has no effect on the total transportation cost. There is no decrease in the total transportation cost, and there is no increase in the total transportation cost. Thus, the net cell cost of 0, whether you move some units into this vacant cell or not, will create no change in the total transportation cost. Again, I will remove this closed path and we will now consider this third vacant cell, ZA. We have considered so far two vacant cells. This vacant cell, XB, with net cell cost of negative 6, which means a decrease in transportation cost per unit of 6 pesos. And this vacant cell, XC, with net cell cost of 0, which means that there is no change in the total transportation cost whether or not you transfer some units in this vacant cell. Now we consider the third vacant cell, ZA. For the vacant cell ZA, we trace again a closed path using a combination of alternating horizontal and vertical movements. And the first movement is always horizontal. From this vacant cell ZA, we move horizontally to the right or to the left. But we cannot move horizontally to the left because this is the supplier Z. Hence, from this vacant cell, we move horizontally to the right. And we cannot move horizontally to the right to this vacant cell, to this cell because it is empty or vacant. And we cannot land on a vacant cell. Hence, from this cell ZA, we move horizontally to the right straight to 93. And the cost associated for this horizontal movement is positive 6. After the horizontal movement, the next move is vertical. And we move vertically upward up to 2. We cannot move vertically upward up to this cell because it's empty. and we cannot move vertically downward because you'll be out of your transportation table. Sorry, this is the initial transportation table. Again, from 93, we move vertically upward up to 2. And the cost associated with this vertical movement is the negative of the cell cost where you came from. Where we came from, which is this cell with 93 units. Negative 13. After this vertical movement, the next move is horizontal. And again, from this cell with 2 units, we move horizontally to the left, straight to this cell with 9 units. Because we should be able to return back to where we started, which is this cell, vacant cell ZA. So we skip 124. If you move from this cell to 124, the next step is vertical movement. But you cannot move vertically downward because this cell is empty. You cannot move vertically upward because this cell is vacant or empty. Hence, from this vacant cell with 2 units, we move horizontally to the left, straight to this cell with 9 units. And the cost associated with this horizontal movement is the positive of the cell cost, plus 8. After this horizontal movement, the next move is vertical movement, either vertically upward or vertically downward. From this cell, if you move vertically upward, you can do that. You will land at an occupied, at a cell with units with, you will land, if you move vertically upward, you will land at occupied cell, and that's okay. But the next move is horizontal. And you cannot move horizontally to the left because this is plier X. Hence, you move from 78 horizontally to the right, and this vacant. If you move horizontally to the right, up to this cell, it's still vacant or empty. Hence, from 9, we move vertically downward and we return to where we started, the vacant cell ZA. The cost associated with this vertical movement, this movement which is vertically downward is the negative of the cell cost of 9, minus 9. Now we compute the net cell cost for CA. 6 minus 13 is negative 7. Negative 7 plus 8 is 1. 1 minus 9 is negative 8. The net cell cost for CA, for the vacant cell CA of minus 8, means that if you transfer some units in this vacant cell CA, the total transportation cost will decrease by 8 pesos per unit. In the vacant cell XB, if you transfer some units in this vacant cell XB, the total transportation cost will decrease by 6 pesos per unit. And that's good. But you will get a bigger decrease, larger decrease in the total transportation cost if you transfer some units in the vacant cell ZA, where the decrease in the total transportation cost is 8 pesos per unit that you transfer to the vacant cell ZA. Hence, it is better to transfer some units to the vacant cell ZA than to the vacant cell XB. But we will not do that yet because we still have one vacant cell to consider, this vacant cell ZB. And let me remove again these arrows. This vacant cell we name as the vacant cell ZB. And we trace a closed path for this vacant cell ZB, beginning with a horizontal movement. And we cannot move horizontally to the left to this cell because it is vacant. So our horizontal movement is to the right up to 93. And for this horizontal movement to the right, the cost is 13 pesos. And from 93, we move vertically, upward or downward. And we cannot move vertically downward because we will be out of the transportation table. So we move vertically upward, and we cannot move vertically upward up to this cell because it's vacant. Yes, you can skip this cell, and from 93 you move straight to this cell, but it is vacant. So we do not move to this vacant cell. Hence, we move vertically upward up to 2 only. And the cost associated with this vertical movement from 93 to this cell with 2 units is the negative of the cell cost where we originated. Negative of 13 minus 13. Sorry, this cost should be 11. We originated from this vacant cell and we move horizontally to the right. The cost associated with this movement is the positive of the cell cost where we originated. And the cell cost of this cell where we originated is 11. So we write 11. And the cost associated with this vertical movement is the negative of the cell cost where we originated. And we started out from this cell in going to this cell. And the cost for this cell where we started is 13. So the cost of this vertical movement upward is negative 13. After this vertical movement, the next move is horizontal. And we do not move horizontally to the right because this is the supplies of the third supplier Z. From 2, we move horizontally to the left. If you try to skip this 124, from 2 you go straight to 9. You can do that. But the next move is vertical. If you move vertically downward, it's vacant. If you move vertically upward from this cell, you can do that because this is occupied. And if you go to this cell, the next move is horizontal. And it's empty. So if you go straight from 2 to 9, you will not be able to return to where you started, the vacant cell ZB. Therefore, from 2, we move only horizontally to the left up to 124. And the cost associated for this horizontal movement is the cell cost of our point of origin, which is this cell with 2 units. The cell cost is 8. Thus, the cost associated with this horizontal movement is plus 8. And after this horizontal movement, the next move is vertical. Now, if you move vertically upward, it's empty. But if you move vertically downward, you will return to where you started. Thus, from 124, we move vertically downward and we get back to where we started. The cost associated with this vertical movement is the negative of the cell cost where you originated. In moving to this vacant cell from 124, the cell cost of this cell is 12, thus the cost associated with this vertical movement is the negative of this cell cost minus 12. And we compute the sum and difference of these numbers to find the net cell cost for the vacant cell ZB. We have 11 minus 13 is negative 2. Negative 2 plus 8 is negative 6. 11 minus 3 is negative 2. Negative 2 plus 8 is 6. And 6 minus 12 is negative 6. Thus, the net cell cost of CB is the same as the net cell cost of XB, negative 6. Which means that if you transfer some units to the vacant cell ZB, there will be a decrease in total transportation cost of 6 pesos per unit that you transfer to the vacant cell XB. Hence, among these, we have 3 options where 3 vacant cells where we can transfer some units you can transfer some units to the vacant cell XB. Decrease in transportation cost is 6 pesos per unit. Or you may transfer some units to CA. The decrease in total transportation cost is 8 pesos per unit. And ZB, you can transfer some units to the vacant cell ZB. The decrease in total transportation cost is 6 pesos per unit. But we want to maximize the decrease in transportation cost so we can minimize the total transportation cost. Therefore, it is best to transfer some units to the vacant cell ZA where we would get the greatest decrease, the largest decrease in total transportation cost of 8 pesos per unit. And I will highlight this by using a rectangular box. To indicate that we would transfer some units in the vacant cell ZA. Now, to determine how many units to transfer to the vacant cell ZA and how do we do that, that's the next step in the stepping stone method. We now determine the number of units that should be transferred to the vacant cell ZA. And we chose to transfer some units to the vacant cell ZA because based from our test for improvement, it is best to transfer some units to the vacant cell ZA because we would get the greatest decrease in the total transportation cost per unit that we transfer to the vacant cell ZA. Now, for our reference in determining the number of units to be transferred to the vacant cell ZA, I wrote again the closed path that we traced for the vacant cell ZA. This is the vacant cell ZA. We move horizontally to the right up to 93, followed by vertical movement up to 2, followed by horizontal movement from 2 direct to 9, and we skip 124. And from 9 we go back to the vacant cell ZA. Now in the second transportation table, we are almost about to develop the second transportation table. In the second transportation table, all the numbers in the occupied cell will remain the same. In the second transportation table, those numbers that are not in the path, in the closed path for the vacant cell ZA. Example, this cell with 78 units, 78 is not along the path of the closed path for the vacant cell ZA. The 78 will remain as is in the second transportation table. And we write that now. You write the numbers that will remain the same in the next transportation table. And we start with 78. "78 will remain as is because 78 is not along the path, the closed path for the vacant cell ZA. The same with 124 because we skip 124 and 124 is not in the path. For the closed path for the vacant cell ZA, we only stop at 93, at 2, and at 9. But we skip 124, thus 124 will remain as is in the second transportation table. And we write now 124, y to be 124. The number of units in the occupied cell that are in the closed path for the vacant cell ZA will all change. This number 9, 2, and 93, they will all change. All the numbers in the occupied cell that are not in the closed path for the vacant cell ZA, where we would transfer some units, will remain the same. So this number 9 will change, and this is initially empty or vacant, and we will transfer some units to this vacant cell. This vacant cell has initially 0 or nothing. So in the second in the second transportation table, we would now have some units in this vacant cell ZA. And 93 would change, and 2 would change. It's because if we transfer some units in the vacant cell ZA, we have to adjust all the other numbers along the closed path in the vacant cell, for the vacant cell ZA, for us to maintain the balance in the transportation table. Now, to determine the number of units to transfer in the vacant cell ZA, we only consider the vertical movements. The vertically upward movement and the vertically downward movement. For the vertically upward movement, we have 93. And we originated from 93. And for the vertically downward movement, we originated from 9. Now, the number of units to transfer in this vacant cell is the number of units between 9 and 93. Now, if you consider transferring 93 to this vacant cell, that would be impossible because we already have 78 units delivered to customer A. And if you add 93 units to A from supplier C, 93 plus 78 would be more than the demand of customer A. So we cannot transfer all of 93 units to this vacant cell ZA. Now consider 9. If you transfer 9 in this vacant cell, you have 9 plus 78. The sum would still be 87, which is the demand of customer A. Thus, we only transfer 9 units in this vacant cell CA. And we will change 93 and 2 to maintain the balance. We now transfer 9 units from YA to ZA in the second transportation table. In the vacant cell ZA, we write 9. Now you check, 9 plus 78 is 87, which is the total demand of customer A. Because we place some units here, 9 units in particular, if you add 9 to 93, the sum would not be 93. So we change 93. The number 93 has to be changed to what number? That number is equal to 93 minus 9. Again, this number 93 has to be changed to the difference, to the number 93 minus 9. And 93 minus 9 is 84. Hence, 93 has to be changed to 84, and we write here 84. Now, in this column, if you add this is vacant 0 plus 0 plus 84, you would only get a total of 84. But the demand of C is 95. So this number this number 2 has to be adjusted also. And this number 2 has to be changed to what number? That number is 95 minus 84, and that's 11. The number 2 here is to be changed to this number, 95 minus 84 is 11. And you write here 11. 2 now will be changed to 11. And this cell from which we get 9 units that we transfer to the vacant cell CA would be empty. This is now empty. Now you check if the table is still balanced by adding the numbers vertically. 78 plus 9 is 87. 124 plus 0 is 124. 11 plus 84 is 95. Also add the numbers horizontally. 78 plus 0 is 78. 0 plus 124 plus 11 is 135. And 9 plus 0 plus 84 is 93. And this is the second transportation table from which we will now develop the second distribution plan. We now develop the second distribution plan corresponding to our second transportation table that we developed from the initial transportation table. And in the second transportation table, we now have 9 units in the vacant cell CA. Now we will check if we would get a lower transportation cost. For the second distribution plan, we write supplier in the first column, followed by demand, and the number of supplies, number of units to be supplied from supplier to demand, the cost per unit, and the total cost for transferring the number of units at the given cost per unit. We only consider the the occupied cell. We start with this occupied cell. From supplier X to customer A, we supply 78 units at 10 pesos per unit. Supplier X to customer A, 78 units. At 10 pesos per unit. And the total cost of transferring 78 units at 10 pesos per unit is 780 pesos. The next occupied cell is this cell, 124 units, which means we transfer from supplier Y to customer B, 124 units at 12 pesos per unit. Supplier Y to customer B. We deliver 124 units at 12 pesos per unit. And the total cost is obtained by multiplying 124 by 12. You use your calculator. 124 multiplied by 12, you get 1,488 pesos. The next occupied cell is this cell. We have 9 units from supplier Z to customer A. We supply 9 units. Z to customer A, 9 units at 6 pesos per unit. For the total cost of 9 multiplied by 6 is 54 pesos. The next vacant cell is this vacant cell, 11 units from supplier Y to customer C. We deliver 11 units at 8 pesos per unit. Supplier Y to customer C. We deliver 11 units at 8 pesos per unit. For the total cost of 11 multiplied by 8 is 88. We already have Z to A in our distribution plan. The last one is this 84 units from supplier Z to customer C, Z to C. We deliver 84 units at 13 pesos per unit. And to find the total cost of transporting 84 units from supplier C to customer C, we multiply 84 by 13 using our calculator. Multiply 84 by 13, 1,092. We have 1,092 pesos, and we add the last column for the second transportation cost. The total transportation cost corresponding to the second transportation table is obtained by adding the last column. So we get the sum of the last column using our calculator. we have 780 plus 1,488 plus 54 plus 88 plus 1,092. And the sum is 3,502. Now we will check if this answer is correct, and we need the initial transportation cost or the total transportation cost corresponding to the initial transportation table, which we developed in the last lesson. And we also need the decrease in the total transportation cost per unit of transferring 1 unit from supplier C to customer A, which is 8 pesos per unit. We now check if our second transportation cost of 3,502 is correct. This is the total transportation cost for the second distribution plan corresponding to the second transportation table. And we would now check if this is correct. From our initial distribution plan corresponding to the initial transportation table, we obtain the initial transportation cost of 3,574. And in the test for improvement, we said that the decrease in the total transportation cost is 8 pesos per unit if we transfer some units to the vacant cell ZA. We actually transferred 9 units to the vacant cell ZA. That will give a decrease of 8 pesos per unit. The decrease is indicated by the negative 9 and by the negative 8 by the negative sign. So negative 8 means a decrease of 8 pesos per unit if we transfer some units to the vacant cell CA, and we actually transferred 9 units to the vacant cell CA. And the decrease in the total transportation cost is 8 pesos per unit. Decrease in the total transportation cost is 8 pesos per unit, and we transferred 9 units, so the total decrease in total transportation cost, the total decrease in the initial transportation cost should be 72 pesos. 9 units we transferred to the vacant cell ZA, and the decrease per unit is 8 pesos. So the total decrease in total transportation cost after transferring 9 units to the vacant cell ZA is negative 8 multiplied by 9, 72, which we subtract from the initial transportation cost. And the initial transportation cost of 3,574 minus the decrease is 3,502, which should be the second transportation cost, and which is what we actually get in the second distribution plan. So our second transportation cost of 3,502 is correct. For your practice, you try the following exercise. Test for improvement. Develop the second transportation table and second distribution plan. Again, to test for improvement, you only consider the vacant cells. And this was the problem, the transportation problem I gave you in the last lesson, the lesson before today's lesson. And in that exercise, I asked you to develop the initial distribution plan. You make the initial distribution in the initial transportation table, and this is actually the initial transportation table, and we check whether this is a balanced transportation problem, and it was a balanced transportation problem. And I also gave you the answer for the initial transportation cost, which is equal to 5,319. And from your initial transportation table, you proceed now with the test for improvement. You only consider the vacant cells and determine which among the cells you considered in the test for improvement should be considered should you transfer some units, and you will transfer some units to the vacant cell with the most negative net cell cost. And I will not give you the answer for this exercise because there is a way for you to check if your answer is correct. From the initial transportation cost, you subtract the total decrease in transportation cost after you transfer some units to the vacant cell with the most negative net cell cost. And the total decrease in the initial transportation cost is the number of units you transferred to the vacant cell with the most negative net cell cost multiplied by the net cell cost of that vacant cell where you transfer some units, which is a negative number. And the product you subtract from 5,319, and you should get the second transportation cost, which you will get from obtaining the total or the sum of the last column of the second distribution plan. And that completes our lesson for today, but the solution of our example is not yet complete. And we will complete that in the next lesson. And in the next lesson for your exercise, you will also complete the solution of this transportation problem. If you have question about the lesson today, you ask your question in the comments below. And don't forget to subscribe to my YouTube channel, Art Canisan, the channel of learning and leisure. You may also ask your friends, your classmates, and neighbors to subscribe to my YouTube channel so they may learn as well. Thank you for joining me in my class today.